See this question. A flat car of mass m0 start moving to the right due to a constant horizontal force F. Sand spills on the flat car from the stationary hopper. The rate of loading is constant and is equal to mu kg per second. Find the time dependence of velocity and acceleration of the flat car in the process of loading. The friction is negligibly small. See here, your sand is spilling. This is stationary hopper. This is stationary hopper from which sand is spilling out. Sand is spilling out from this stationary hopper. Alright. So in this case, this is a system where the mass is increasing. The flat car is the parent body, and with respect to time, the mass of the flat car is increasing. Mass of the flat car is increasing. Right. First of all, this is one force. Then you have a force normal reaction, then mg, but n and normal reaction won't be contributing anything to the motion in horizontal direction. So this force will be contributing to the horizontal motion, and we must find out the thrust for acting on the, we must find out the thrust force acting on the flat car. Thrust force is given by Ft equals to VR dm by dt. VR is the relative velocity of the added mass with respect to the flat car. Suppose at time t, the velocity of flat car is v. So what is, this is stationary hopper, this is moving with v, this is stationary hopper, and the flat car is moving with velocity v. Suppose at time t, the velocity is v. Velocity is v at time t. So what is the relative motion of the added mass with respect to parent body? For that, you keep the observer over here and you just see what velocity is seen by this observer. What is the velocity of this sand particles, sand, with respect to this observer? What is the velocity of sand with respect to this observer? See, no observer see his frame to be moving, so this observer is going to see the flat car to be at rest. This observer is going to see flat car to be at rest. In that case, he will see this sand particles moving in left direction. Get my point or not? This observer is on the flat car. So observer on the flat car will see the flat car to be at rest. So he will see the sand particles, he will see everything moving towards backward direction. So he will see this sand particle moving in the left direction, moving in backward direction, right? So the velocity seen by the observer on the flat car is v towards left, right? So in that case, the VR is towards left and dm by dt is positive. So the thrust force is going to be, VR is v into dm by dt. And what is dm by dt? It's written, rate of loading is mu kg per second. So it is mu into v. Mu into v. This is the thrust force. So since dm by dt is positive, thrust force is going to lie in the direction of relative velocity, since dm by dt is positive. So this will be mu into v. This is going to be mu into v. Alright. So the net force acting on the flat car is going to be F minus mu v, and that should be equal to m dv by dt. So I can write, what is m? Mass at time t is going to be m0 plus mu t. Mass is increasing. So I write m0 plus mu t dv by dt F minus mu V, or I can write dV upon, and this is dt upon m naught by mu t. So I'll integrate this. At time t equal to 0, your velocity was 0, since the flat curve starts from rest, starts moving. Yes, initially the velocity was 0. At t equal to 0, velocity was 0, and at t equal to t, the velocity was v. So that comes out to be minus 1 upon mu f minus mu v, 0 to v, and 1 upon mu log m naught plus mu t, 0 to t. So this mu and mu will cancel out. So this comes out to be f minus f by f minus mu v log f by, if I put v, this will come in there, this is minus sign, I am absorbing minus sign inside, and log upon m naught. So this comes to be f and m naught mu t upon m naught. So m naught f and f minus mu v. See, m naught f mu m naught v plus mu f t right, this. So this will cancel out, this will cancel out, and mu will also come out. So v comes out to be, ft upon m naught upon mu t, ft upon m naught plus mu t. That's the velocity. That's the velocity. Okay, that's fine. And acceleration is dv by dt. So that will come as square, and you have f mu t minus ft into mu. So that is m naught f. That's the acceleration. This is the acceleration which I can get, right? So this is the acceleration. So this is how we will solve this problem, right? Now let's move to next question. Say this is the question. The cart loaded with sand moves along the horizontal force F, coinciding in direction with the cart velocity vector. In the process, sand spills through the hole. This is the hole, sand is spilling out of it with a constant rate mu kg per second. Find the acceleration and velocity of the cart at time t if at initial point t equal to 0, cart with loaded sand had the mass m naught and velocity was equal to 0. So here it is, the mass is falling, mass is decreasing, right? Mass is decreasing in this case. So let's find a thrust force. What will be the thrust force? What is going to be? The sand is spilling out. Spilling out means it is just leaking out, right? So if I keep my observer on the parent mass, can you tell me what is the velocity seen by this observer when sand is just ejected? See here, this observer inherit the velocity of the flat car, and sand which is coming out is also inheriting the velocity of the cart. this observer is inheriting the velocity of the cart, and the sand which comes out, this sand particle, also inherit the motion of the cart. So he also inherit the motion of the cart, sand also inherit the motion of the cart. So this observer, when the sand is just ejected, he won't see any motion in the sand particle. He will see the sand particle to be at rest. He will see sand particle. He won't see any relative motion of the sand. He won't see any motion in the sand particle, because both are observed. This observer is also inherit the motion of the cart. Sand particle also inherit the motion of the cart. So he will be seeing. He won't be seeing any velocity in the sand which is spilling out. So in that case, the relative velocity of the sand which is just ejected, sand which is leaking out, which is spill out, with respect to flat car is 0. The relative velocity of the sand which is spills out, see, the relative velocity of the sand particle which is spill out of this cart with respect to the cart is 0, right? So if it is 0, the thrust force acting is 0. So the only force is F, and this will be equal to m dV by dt. There is no thrust force, and m is what? M is m naught minus mu t, and that is F. So we can solve this. We can write dV equals to, or dV equals to F dt. So acceleration, you get, acceleration is F upon m naught minus mu t, right? F upon m naught minus mu t. We have to find velocity. So velocity we can find out, F dt m naught minus mu t. So I can integrate, right? At t equal to 0, v is 0, and at t equal to t, the velocity is v. Velocity is v. So this becomes v equals to F upon minus mu log m naught minus mu t. So that becomes 0 to t. So that becomes as, so this is minus F by mu log m naught minus mu t upon m naught, or I can say velocity of the flat car is F upon mu m naught minus mu t. That's the velocity of the flat car. That's the velocity of the flat car. Okay. We will see some more cases when we will study fluid dynamics. Fluid system is also variable mass. Sometimes fluid, when they ejected out, also behave like a variable mass system. Like you have the fluid and you have some orifice, fluid comes out. This is also variable mass system. So we will consider these cases. The vessel filled with water and water comes out. What is the thrust force? We will see these cases in fluid dynamics, right? So I'll recall this topic when I'll teach you the fluid dynamics, right? So this is the variable mass system. It's a very small topic, right? It is a part of, we can say, the law of conservation of linear momentum. Okay. Thank you very much.